So in this video we will be resuming. So in the part 2 we have seen about round robin, weighted round robin and least connections, and I will try to cover the other 3 in this, and I will be keeping the videos short. We will be not seeing any pros and cons in this. So we will be seeing about weighted least connection, and then we will be seeing about IP hash. IP hash is a bit very interesting load balancer, and we will be then seeing about least response time, LRT. Okay, so let's start with WLC, that is weighted least connection. Okay, so what is weighted least connection? Weighted least connection is a dynamic load balancer algorithm that combines server capacity awareness with real-time load awareness active connections, that is active connection. So क्या होता है ये कि अपने पास में बहुत सारे डिफरेंट सर्वर्स है. एग्जांपल लेके देखते हैं. पहले तो हम लिख लेते हैं कि इसका एक बेसिक सा फॉर्मूला है कि इफ़ेक्टिव लोड जो होता है ना, वो होता है एक्टिव कनेक्शंस प्लस वेट. ये वेटेड लिस्ट कनेक्शन का बेसिक फार्मूला है. अभी अगर मैं एक एग्जांपल लूँ तो मान लो अपने पास में 3 सर्वर्स है. वी आर हैविंग सर्वर ए, वी आर हैविंग सर्वर बी, वी आर हैविंग सर्वर सी. Okay, and we are having some weight, we are having active connections, and we are having some effective load. So if the weight is 1 and connections are 10, the load will be 10. How it is calculated? 10 by 1. Okay, now the weight is 2 and active connections are 14, so effective load will be 7. 14 by 2. Now weight is 4 and active connections are 20, so it will be 5. Okay, that is 20 by 4. So although server C is having the highest number of active connections, but the next request will be sent to the server C only, because the effective load is least. This is everything about weighted least connections. Okay, I hope this example cleared that how the active weighted least connection works. If I consider this with an example, so consider again we will be taking Virat Rohit. Virat is one client, Rohit is another client. Okay, and there is some load balancer, and there are and there are some servers. This is server 1, this is server 2, this is server 3. Okay, and server 1 is having 1000 connections, server 2 is having 12 connections for example, and server 3 is having 10 connections. Okay, and server 1 is having weight of 0.5, server 2 is having weight of 0.2, and server 3 is also having weight of 0.2. Now if 1 and 2 is coming from here and 3 and 4 is coming from here, so what will happen, as we can see that it is having the least number of connections, this is having the least number of connections, and as the weights are same, so first of all it will try to overfill this. The 3 will come here and the 4th one will go here. That is how the least connections work. I hope this figure would have cleared some have brought some clarity. And if we take some real life examples, okay, so we can take a payroll system. Let's take payroll system in workforce management. Okay, so here some nodes can be optimized for batch jobs, and other may handle real-time users interaction. So in this case we can use least connections. So this was all about weighted least connection. Now let's move to the most interesting one and most complex one, that is IP hash. This is one of the load balancer technique which I took some time to understand. So what is IP hash? It is a technique that assigns client request to servers based on the client's IP address. क्या होगा, हमको कुछ क्लाइंट रिक्वेस्ट आएगी और उसके क्लाइंट आईपी को ये इंटरनली एक हैश वैल्यू में कन्वर्ट करेगा और उस हैश वैल्यू से डिटरमाइन होगा कि कौन से सर्वर को उस रिक्वेस्ट को हैंडल करना चाहिए. दिस इज़ ऑल अबाउट IP हैश. मैं एक एग्जांपल से इसको समझाने की कोशिश करता हूँ. सो फर्स्ट ऑफ ऑल एक फॉर्मूला है इसका. क्या है? सर्वर विल बी इक्वल टू हैश दैट इज client IP and that will be quotient of number of servers. ठीक है, please remember this. Okay, and now we will quickly jump to the example. Now assume there are three servers, that is server A, server B and server C, and they are having some hash IDs, that is 0, 1 and 2. Okay, keep this in mind. Now there are some clients, these are incoming clients, and there is some hash value. Now how hash value is internally calculated, we will not go into that depth. You can Google it, but I will be assuming some values, and selected server we will be saying. Sorry. So let's take example. IP is this, hash is 7. So 7 will be divided by 3, the quotient of 3. So 1 will be the remainder, and it will go to the server B because the hash ID is B. Now for example, the hash is this, and the IP is this, and the hash is 5. So 5 will be this, and it will be 2. So it will be go to C. This is C. So here this is the hash value, this is the hash value, and this is the number of servers as we saw in this example. Okay, and if we talk about some if we try to understand with some diagram, so again we will go to Virat, we will be having a Rohit Bhaiya, we will be having a LB, we will be having some server 1, we will be having some server 2, we will be having some server 3. Okay, so let's take the hash values. Let's take this is having hash 2, let's take this is having hash 4, let's take this is having hash 6. Okay. So for I will not take some client IDs. Let's just say there is some client ID with 1, then 2, then 3, then 4. Assume such kind of client ID. So it will calculate, and it will like go to the different what we can say hash values. For example, here it will 1 and 2 will go here, then the 3 and 4 will go here. It will work in that manner. Internally it will calculate that, and it will go there. Now if we talk about some real life scenario, so consider an HR portal where user session data lives in JVM memory on each node. Okay, in this case this IP hash can work. IP hash is a bit of complex thing, but it is very interesting, and this was all about IP hash. Now let's dive to the next one, the last one for this video. That is least response time. So first of all, the name itself says the least response time will come from the fastest server. Okay, so that is the thing, fastest server. Okay, so least response time is a dynamic algorithm that assigns incoming request to a server with lowest response time. Okay, and ensuring efficient utilization of server resources and optimal client experience. So let's take an example. Consider you are in a supermarket, and there are 3 supermarket bill desk. Okay, so cashier A, let's say it is tired, so it is a slowest one. Cashier B is okay, so it is a medium speed one. Now cashier C is energetic, so it is a fastest one. Now if we are managing the queue, we will of course send our customers to the cashier which is finishing the customers first, which is this one. Okay, so this is also the least response time also works in the similar manner. You have to understand this. Okay, so let's take a figural example. For example, there is one Virat, for example there is a Rohit, there is one load balancer, there are 3 servers, server 1, server 2 and server 3. Okay, and let's see, this is having the speed of 10 ms, this is having the speed of 5 ms, and this is having the speed of 1 ms. So what will happen? The request will come, 1 2 3 4 will come, and it will all go here because it is taking the least time. Okay, the least response time. And then it will ask, see, don't get confused in the language. Least response will be given by the fastest server. Okay, don't go into the depth of English here. सबसे मतलब सबसे जब सबसे कम रिस्पॉन्स सबसे फास्टेस्ट से आएगा, ठीक है, ये बेसिक क्रक्स है इसका. सो दिस वॉज ऑल अबाउट दिस वीडियो. आई ट्राई टू कवर द क्रक्स ऑफ एवरीथिंग in a much better manner. We are not going into the code depth. We are trying to understand. We are trying to understand some theory with some figures. Okay, so thank you guys. Thank you. If you are having some suggestions, you can add in the comment. If I went wrong somewhere, you can add. You can correct me always, and you can, if you are having some extra data, you can comment so we can share that with each other. Thank you. Have a nice day.